In this video, we're going to do an example of state programming. And so we have the Romy set up here, and we have one state is to follow the line. So we'll follow the line, and then once it reaches the end of the line, it will stop and pause, and we'll go ahead and tell it to proceed, and then it will move forward about a fifth of a rotation of the wheels to make sure it's off the black line. And then it will do a turn until it finds the black line, and then it'll proceed and follow the line again and just go continue to go through that process. And also we'll have an emergency stop button. So just to demo this, okay, so I'll push the button here. And now it's waiting for me to push the up arrow, and see it moves forward a little bit more. Now I'll push the up arrow again. It'll start to turn, and I'll push the pause button to stop it. Push the up arrow again for it to proceed. Push the up arrow again. Start line following again. Push the up arrow again so it'll move forward a bit. Okay, and then push the up arrow again so it will turn again. Stopped on the line. Push the up arrow again. It follows the line, and so on. So we'll just keep moving from one state to the other and just keep repeating that process. Okay, so now we'll look at the code and the zip folder with this on the Canvas site. But you can see just pretty much standard stuff, setting up all the pins here. I'm going to use a speed of 8 centimeters per second for following the line, turning 4 centimeters per second, and then stop to 0, of course. And we have we're using the Pololu reflective sensors. And so I think this is all pretty straightforward. And so we set things up. We're going to set follow line as assign that as the initial state, and have the wait for the button B to be pressed. And then we have this function that if the key is pressed on the remote, and there's just two buttons in these if statements right here. You can see one is the pause button, so that's the emergency stop. So what that does is it saves the state, we call that next Romy state, and then makes the state stop. So it does the emergency stop and just waits in the stop state until you press the up arrow, and then it says Romy state equals next Romy state. So in other words, we save whatever state it was in the process of executing, do the emergency stop, wait in the emergency stop state, and then when the up button is pressed, it picks up where it took off, the state that it was previously in before the emergency stop was hit. And so at the loop, again, this has to be non-blocking. So we just every time through the loop, just grab the key, see if a key has been pressed. If a key hasn't been pressed, then the decoder.get key code will return a -1. So if not -1, then it calls that function and checks to see whether the pause was pressed or the up arrow was pressed. Okay, so there are 4 states. I'll just go back up to here. You can see the state choices for there's 2 variables, Romy state and next Romy state. And they both have the same choices: follow line, turn to line, move to count 300, and stop. So let me just explain those states. Okay, so the first state is follow line, and that just simply gets the analog readings from the 2 reflective sensors and uses twist forward wheels. Remember, that was 8 centimeters per second. And then just has a proportionality constant times the difference between those reflectance values. And then when they're both less than 70, then we know we've passed the line, we've driven past the end of the line, and so we want to stop and move on, set the next state to move to count 300. Again, that's just 300 ticks. On this base, there's 1,440 ticks per revolution, so that's about a fifth of a revolution. And set the state to stop, and then what we're going to do is reset the count. So if you do get left encoder count and put in the true value here, that resets it to 0. But if we just said left encoder value equals chassis dot get left encoder count with true in it, it would reset the value, but it would give us the current value, not the reset value. So that's why that's called first, and we want to reset that before we enter the move to count 300 state. Okay, and then we just print out that value, and then the move to count 300, it's going to set the wheels, just the speed to forwards divided by 2. So that would be 4 centimeters per second. And we want to move for about a fifth of a revolution. So we have left encoder value, set that to the encoder count, and then just keep proceeding until that encoder count is bigger than 300. And then we'll just stop that and print out, just do a check. So in other words, our encoder count might be slightly over 300 because, again, the robot has some inertia. So from the time we hit tell it to stop, it might move forward a bit more. Okay, and then from that point, we want to turn to the line. So that state, right, and that state is set speeds to minus turn wheels and plus turn wheels, and it keeps, it stays in that state until one or the other reflectance sensors is bigger than 200, which means you've picked up the line again. So then set the next state to follow line and so on, and then stop is just sets the speeds to stop wheels as a 0. So the way that this is set up, like for each case, when it ends, I've had it go to stop, which means that before it proceeds to the next state, you have to hit the up arrow. For your project, this is just a sample. Again, this isn't like something you should use exactly for your project, but you don't have to. If you have a series of states and you don't want any pause, then you don't have to put in stop. I mean, you can just say Romy state equals whatever you want the next state to be. You don't have to have this next Romy state line. You can just go right to the next state. But just for demonstration purposes, I wanted to have that. And then, of course, the other way to get to the stop state, suppose you're in this turn to line state and you haven't reached the line yet, so this if statement isn't true, but you click on the emergency stop, right? If you click on the emergency stop, then, the next time through the loop, it's going to read that code and execute this, and then save the state that you're in and set the current state to stop. All right, and it will just sit there until, and keep looping through the program. It's non-blocking, right? Until you press the up arrow, and then, whatever you saved here, whatever that current state was, is put in next Romy state. So then it states the current state to next Romy state and picks up, if you were turning towards the line and hasn't reached the line yet, then it will just go back to what it was doing. Right, if you look at turn to line, it's going to enter this state again. It's going to check the reflectance sensors, and if neither of them is bigger than 200, then it's just going to continue turning as before, right? Set wheel speeds. This again was just set, for this particular program was set to 4 centimeters per second. So it's just going to keep turning until this if statement is satisfied, and then it will proceed on to the next state. So, okay, so what we'll try to do now is run the program with the the terminal output here going. So hopefully this will work now. And I'll press proceed. And I'm going to press the pause button and then proceed again. Proceed. Let's see. Right, and then proceed again. Moves forward a little bit. And proceed again. And proceed again. Okay, so disconnect that, and let's look at what we have here now. Okay, so I press the button. It moved forward to the end of the line, set the encoder value to 0. Then it moved forward 300 encoder counts. You can see it did that. End of move to 300. Proceed. Then I hit the emergency stop, so it stopped. Then proceed again. End of terminal line. Proceed. Right. It followed the line again to the end, and then stopped, and then set the encoder value to 0. Then it moved forward a bit more. Right. End of follow line. Stop. The encoder value again was reset. Went to 301, and turn the line, and so on. So seems to be working fine. The emergency stop worked, and the pause at the end of each state worked. So anyways, as I said, this code should at least give you a good idea of how to start building your code for the final project.